States का नोट अगर बनाना है शुरू करें.
हाँ.
Now we start the module 2 of this course. So you recall that in the module 1 we spent our time understanding about descriptive statistics. In particular, we looked at how we summarize a categorical variable and a numerical variable, and we also spent time to understand how we describe association between variables when both the variables are categorical, when both of them are numerical, and one of them is categorical and numerical. So till this time we spent our energy and understanding to look at how we describe data that is given to us. We did not use the data to look into the future. Everything was clear about the data. It was certain about the data. There was no element of uncertainty that was there in our data that we looked so far. But however, we also know that we want to use the statistics as a tool to infer about the unknown. In other words, we are faced with uncertainty most of the times, and whenever we are faced with uncertainty, we want to see whether we can have a framework or a tool that would help us predict about the uncertain or understand the uncertainty with a certain degree of confidence. Now, probability is a very powerful tool to help us understand this uncertainty. So, in this module, we are going to understand about probability. We are going to introduce the notion of probability, and we are going to look at how we can formalize certain intuitions which we already have in an uncertain world in the domain or in the framework of probability. But before we go and understand probability, what we are going to do is to try and understand about certain basic counting principles. All of us would have studied in high school about permutations, combinations and fundamental principles of counting. We just revisit that basic fundamental principle of counting along with a revision of concepts from permutation and combination this week. So, let us get started. So, what are the learning objectives here? So, you can see that the learning objectives I am going to have here are the following. So, the basic objectives, the learning objectives of this week are: we understand what are the basic principles of counting, then we introduce the concept of factorials and what are the simplified expressions that we can have using the concept of factorials. Then this is the key thing, we will understand what is the counting with order and counting without order. In other words, what is the difference between permutation and combination. And finally, we will use the concepts of permutation and combinations to answer a few applications that arise in real life. So, this is the agenda for the week. Now, let us start going. So, the first thing is we start with a basic example of counting. Now, what you can see on the screen is, suppose I have a gift card from a major retailer which specifies the following: you can buy one item and that item can either be a shirt or a pant. So, the specification is you can buy a shirt or a pant. We assume now that the shirts and the pants are priced the same. We are not assuming it. So, you have a gift card for certain denomination, and what is specified in the card is you can buy a shirt or a pant. Okay. Now, when you go to the shop, you notice the following. You see that you have a choice, the first choice, which is a yellow shirt or a blue shirt or a green shirt or a red shirt. But when it comes to pant, I have three choices. I can either buy a black pant or a blue pant or a brown pant. Now, if I exercise my gift card or I use my gift card to buy a yellow shirt, I have exhausted my option. Similarly, if I use my gift card to buy a blue pant, I have exhausted my option. So, the question here we are asking is, how many different ways can I use my card? So, the answer is, I can either buy a yellow shirt or a blue shirt or a green shirt or a red shirt. So, I have basically the number of options available to me. So, the question is, how many different ways can I use my card? To answer this question, I have how many choices to buy a shirt? I have 4 different choices to buy a shirt. I could have bought a yellow shirt or a blue shirt. Okay, those are the choices that are available to me, or a green shirt or a red shirt. These are the 4 different choices available to me. I have 3 different choices when it comes to a pant. I can buy a black pant or a blue pant or a brown pant. But what I need to remember is, if I buy a shirt, I cannot buy a pant. If I buy a pant, I cannot buy a shirt. So, the total number of choices that are available are the 4 choices which come from the shirts and the 3 choices that come from the pant, and the total number of choices 4 plus 3, which is equal to 7. So, here when I am talking about a dependency, that is, what do I mean by dependency? Here the actioner is, you either buy a shirt or you buy a pant, but I cannot, the actions are dependent. What do I mean by dependent? I cannot buy a pant if I have bought a shirt, and I cannot buy a shirt if I have bought a pant. So, in a sense that actions are dependent on each other. I have 4 choices for my first action, which is buying a shirt. I have 3 choices for the second event, which is buying a pant, and the total number of choices available here are the addition of the choices available for each of the action, which is 4 plus a 3, which is equal to 7. So, you can see that this is what I can formally state as the addition count rule of counting, which I can state as, if an action A, the action A in my example could be buying a shirt, can occur in n1 different ways. So, n1 in my example was 4. Another action B could be buying a pant. This can occur in n2 different ways, which is 3. Then the total number of occurrence of actions A or B is given by n1 plus n2, which is given by n1 plus n2. Okay. So, now this is what we refer to the addition rule of counting. Now, let us revisit the same example. Now, suppose my card allows the following. Initially, my card said you choose either a shirt or a pant. So, it was very clear. The card said you choose either a shirt or a pant. Okay. But now suppose the card allows you to buy one shirt and one pant. It is not allowing you to buy 2 shirts or 2 pants. It is allowing you to buy one shirt and one pant. Now, how many choices do we have in this case? Again, let us go back and we can see that I have 4 shirts. Okay. So, this is my shirt 1, a yellow shirt, a blue shirt, a green shirt and a red shirt. I have a black pant, I have a blue pant and I have a brown pant. I can combine a yellow shirt with a black pant, a yellow shirt with a blue pant, a yellow shirt with a brown pant. This is one. So, how many ways can I buy it? I can, when I am looking at the yellow shirt, then I can see that a yellow black, a yellow blue and a yellow brown. Okay. So, that will give me 3 options, 1, 2 and 3. Similarly, what I can do is, I can have a blue. So, you can see a blue with brown, blue, and a blue with brown. So I have 3 options from here, 1, 2, 3. Blue again I have another 3 options. I go to the next one, a green with a black, green with a blue and a green with a brown. So I had 3 options here. I had 3 options with blue, I have 3 options with green, and I finally have 3 options with orange also. So this is my 3. I have 3 options here, I have 3 options here, I have 3 options here, and I can see that what is the total number of things? I have 3 here, plus a 3, plus a 3, plus a 3. So I have a total of 12 options that are available for me to pick a shirt and a pant together and buy a pair of shirt and pants. These are 12 options that are available. Now what do we mean by this? So now let's look at this. I can represent it by what I call is a tree. So if you look at the shirt options, which is given at this level, I have a yellow shirt, I have a blue shirt, I have a green shirt, and I have a orange shirt. With every yellow shirt, I could either have a black pant. So this is yellow with black, a blue. So I have a yellow with blue, a brown, yellow with brown. Similarly, I have a blue with black, blue with blue, and blue with brown. And you can see that the total number of ways I can do it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this sets the ground to understand what we refer to as the multiplicative rule of counting. What is the multiplicative rule of counting? Tell me. Before I go to multiplicative rule of counting, let's go to another example. So suppose I have 4 shirts, I have 3 pants, and now I am allowing with the gift card to choose either black pair of shoes or brown pair of shoes. So I have 2 pairs of shoes I can choose. Now I know that I can have 12 if I am pairing or matching shirts and pant. Now with every pair of your pant and shirt, you can either go with a black shoe or a brown shoe. So what I get is, with each I had 12 pairs of my yellow and black pant and shirt, and now you can see that I have, for each of those 12 pairs, I am having a black shoe. So this gives me 12 ways. The same 12 pairs with a brown shoe gives me 12 ways. So I have total 24 ways of matching the shirts with the pant and the shoes. Okay. So now if you go back and look at a decision or a tree, if you go back and look at a tree diagram, this is the huge tree. So I have a yellow shirt. With a yellow shirt, I could either have a black pant, a blue pant, or a brown pant. With a yellow shirt and a black pant, I could either have a black shoe or a brown shoe. With a yellow shirt, a blue pant. So this is my pant, this is my shirt, this is my shoe. With a yellow shirt and a blue pant, I could again have a black shoe or a brown shoe. So you can see, if I number the total ways of having this, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can keep going, and you can see that the total number of ways is going to be, so I have a 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. This is precisely what we had in our earlier slide, that total 12 plus 12 is equal to 24 ways. So what are we doing here? So you can see that I can state what is popularly known as the multiplication rule of counting. What is the multiplication rule of counting says? It says that if an action A can occur in n1 different ways. What is an action A? It was choosing a shirt. How many ways I could choose a shirt? I could have chosen a shirt in 4 different ways. Another action B can occur in n2 different ways. Choosing a pant, and that could have occurred in 3 different ways. Then the total number of ways A and B. A and B. Earlier we looked at A or B. Now we are looking at A and B is 4 into 3, which is 12 ways. Suppose I have R action. So in a third example, we had 3 actions. What was it? In addition to the shirt and pant, I had to choose a shoe. So the shirt was occurring in N1, which is 4 ways. pant in 3 ways, shoe can be chosen in 2 ways. The total number of ways I can have all the 3 actions occurring, that is choosing a shirt and a pant and a shoe, is 4 into 3 into 2, which is 24 ways. Okay, I can extend this to any sequence or order of R actions, and N1 into N2 into NR will give me the total number of possibilities altogether for all these R actions to occur together. And this is what we refer to as the multiplication rule of counting. So now let's apply the multiplication rule of counting to create an alphanumeric code. Many a times whenever we log in into some website, it asks us to generate a password. Suppose I am logging in into a website which is asking me to generate a password, and what it is telling me is you generate a 6-digit password. The first 2 digits should be alphabets and the next 4 digits should be numbers. Okay, so the first action is to fill in the first space. How many ways can this be done? I can choose any one of the 26 alphabets to be here. Again, this second space is again an alphabet. I can choose any one of the 26 alphabets again here. So in the first case, if I allow repetition of my alphabets, the first can be chosen in 26 way, the second can be chosen in another 26 way. Now numbers, if I include 0, this has a 10. I can do this choice for this blank in 10 ways, this again in 10 ways, this again in 10 ways. So I have actually 6 actions. The first action is to choose an alphabet for the first blank. The second action is to choose an alphabet for the second blank. The third action is to choose a number for the third blank, and so forth. The sixth action is to choose a number for the sixth blank. So the total number of ways I can create, or total number of codes I can create, is 26 into 26 into 10 into 10 into 10. So that is what I have here, which is 26 into 26 into 10 into 10 into 10, which is this number, which is 6,760,000 okay, ways to do it. Now suppose I do not allow repetition. What do I mean? You can see that when I look at the alphabets here, if I have chosen an alphabet to fill in the first blank, I have only 25 alphabets available to fill in the second blank. So I have 25 here. So these 2 blanks, or the first 2 blanks together, can be filled up in 26 times 25 or 26 into 25 ways. Similarly, the third blank, which has to be a number, for the first blank I have 10 choices. Now once I have the 10 choices and I am not repeating that number, I only have a 9 choices for the second blank. I am again not repeating it. I have 8 choices that are left over for the third blank, and for the last blank I have only 7 choices that are left over. Now applying the same, so I have here R actions, 26 choices for the first action, 25 choices for the second action, 10 for the third, 9 for the fourth, 8 for the fifth, and 7 for the sixth action, which gives me the total number of ways is 26 into 25 into 10 into 9 into 8 into 7, which is 3,27,006, which is this number, 3276000. Okay. So you can see that how we can apply a basic principle of counting to something which we generate almost on a daily basis. And every time you want to generate an alphanumeric code, you know that you can choose from this number. Okay. So in summary, what we have learned so far is, first we have introduced what is the fundamental principle of counting. We say that the fundamental principle of counting is, again we looked at the addition rule of counting. Here it is n1 plus n2. Here basically it's action A or action B. n1 into n2, where it is action A and action B, and I can extend this logic to R actions.
I'm just stressed out. I'm trying to.
हाँ जी, आ गया कंटेंट, समझ में आ गया आप लोगों को?
हेलो
हाँ, कह रहा हूँ कंटेंट आ गया समझ में।
आपकी आवाज नहीं आ रही है।
मेरी आवाज़ आ रही है, नहीं आ रही?
बहुत धीमी आ रही है।
1 मिनट, मुझे ईयरफोन लगाना होगा। हेलो,
हाँ।
अब आ रही है आवाज़?
हम्म।
तो शिल्पी आप हैं इधर? वो कह रहा था कंटेंट
हाँ
कंटेंट आया समझ में वीडियो का।
हाँ
हाँ हाँ आ रहा है।
तो ठीक है, अब इसका एक्टिविटी करते हैं। एक्टिविटी कैसे करेंगे? साथ।
इसमें ना मुझे एक डाउट था।
हाँ पूछिए।
जैसे इसमें अभी मल्टीप्लिकेशन रूल जो बताया है काउंटिंग का,
हाँ
इसमें बताया रहा था कि रिपीटिशन अलाउड है, वो पासवर्ड वाला जो एग्जाम्पल दिया था।
हाँ
तो उसमें अल्फाबेट तो 26 थे, ले लिए हम लोगों ने।
हाँ।
और उसके बाद रिपीटिशन अलाउड था, तो सेकेंड वाले में भी फिर से 26 ले लिए। फिर जो नंबर्स लिए हम लोगों ने वो 10 क्यों लिए हैं?
1 मिनट।
नंबर्स 1 to 10 ही लेंगे ना।
1 to 10 नहीं है, सॉरी, 0 to 9।
हाँ 0 to
हाँ।
9 तो 10 ही हुए ना।
अच्छा अच्छा, ठीक है ओके।
तो अभी एक्टिविटी कैसे करेंगे? एक्टिविटी साथ में करते हैं, मैं स्क्रीन पे करूँगा और सब लोग साथ में कर लेंगे। उसके बाद जब सब हो जाएंगे, एक्टिविटी हम सही हो जाएगा, तो फिर आप लोग भी अपने एक्टिविटी वाले टैब में जाके आप उसको टिक कर लीजिएगा मैच करके। साथ में
ठीक है।
साथ
ठीक
में
है।
कर लेते हैं, उसके बाद फिर आप लोग उसको टिक कर लीजिएगा।
हम्म।
जैसे यहाँ पहला क्वेश्चन है कि ए स्टूडेंट विशेज टू टेक आइदर ए स्टैटिस्टिक कोर्स और ए मैथमेटिक कोर्स बट नॉट बोथ। If there are 2 statistics and 4 mathematics courses for which the student is eligible, then the number of ways the student can choose the course is। क्या कह रहा है कि स्टैटिस्टिक्स के 2 वेज
मैं
हैं
एक्सप्लेन करूं?
फॉर एंड 4 मैथ का। हाँ बताइए।
हाँ मैं ये बोल रही हूँ, मैं एक्सप्लेन करूं इसको।
हाँ करिए।
इसमें ये बोल रहा है कि एक स्टूडेंट है, उसको स्टैटिस्टिक्स और मैथ्स के 2 कोर्सेस अवेलेबल है। दो में से वो एक ही ले सकता है, दोनों नहीं ले सकता है। तो इसमें और का वर्ड मतलब और यूज हो रहा है कि या तो स्टैटिस्टिक्स ले या फिर मैथ्स ले, दोनों एक साथ नहीं ले सकता है। तो 2 स्टैट्स के कोर्सेस है हमारे पास और 4 मैथ्स के हैं। तो इसमें हम लोग एडिशन परफॉर्म करेंगे, एडिशन रूल, तो 2 + 4 6 आएगा।
ठीक है।
हाँ
अच्छा, नेक्स्ट देखते हैं क्या कह रहा है कि there are 13 flights from Delhi to Bangalore and then 6 flights from Bangalore to Chennai. Riddhi wants to fly from Delhi to Bangalore and then to Chennai. How many choices does she have for her flight plan? 1 मिनट। ये है दिल्ली टू बैंगलोर, फिर है बैंगलोर टू चेन्नई। देयर आर 13 फ्लाइट्स फ्रॉम दिल्ली टू बैंगलोर में 13 फ्लाइट्स हैं एंड देन 6 फ्लाइट्स फ्रॉम बैंगलोर टू चेन्नई है। तो रिद्धि वांट्स टू फ्लाई फ्रॉम दिल्ली टू बैंगलोर। पहले रिद्धि यहाँ से यहाँ जाएगी, फिर यहाँ से यहाँ जाएगी। तो हाउ मेनी चॉइसेस शी हैव?
78।
13 into 6।
इंटू 6।
हाँ वही 78।
ओके, थर्ड वाला क्या कह रहा है? रोहन पैक 4 शर्ट्स, 4 शर्ट्स, 5 पैंट एंड स्वेटर। स्वेटर जो है वो एक है। For his school trip, he will need to choose a shirt and a pant for each outfit and decide whether to wear the sweater. Decide whether to wear the sweater. Find the total number of possible outfit. कह रहा है कि he will need to choose a shirt and a pant for each outfit में शर्ट और पैंट रहेगा and decide करेगा whether to wear the sweater। स्वेटर पहन भी सकता है और नहीं भी पहन सकता है। तो उसके पास कितने ऑप्शन है? यार ये मेरा, हाँ क्या कहता, 4 था उसके पास शर्ट एंड 5 था उसके पास पैंट और स्वेटर के लिए उसके पास पहनने और ना पहनने के 2 ऑप्शन है, तो टोटल कितने ऑप्शन है?
टोटल 20 होंगे।
शिल्पी?
हाँ हाँ 20 होंगे।
नहीं,
हाँ
मेरा आंसर 40 है।
40 क्यों? अच्छा एक सेकेंड हम लोग फिर से
एक
करते हैं।
सेकंड।
बहुत सिंपल है, देखिए 4 शर्ट है और 5 पैंट है, इसके साथ तो उसके 20 पेयर हो गए।
हाँ
उसके बाद स्वेटर का उसके पास ऑप्शन है पहन सकता है और नहीं पहन सकता है, 2 ऑप्शन है स्वेटर में।
अच्छा तो स्वेटर पहनने वाले 8 बार निकालेंगे और फिर स्वेटर
हाँ
ना पहनने वाले 1 बार निकालेंगे,
हाँ,
तो
वेदर टू
टोटल
बी।
20 + 20 40 हो जाएंगे।
हाँ,
अच्छा ओके।
तो कह रहा है इन हाउ मेनी वेज कैन ए नंबर बी चूजन फ्रॉम 1 to 20 सच दैट इट इज ए मल्टीपल ऑफ 2 और 3। ये देखिए क्वेश्चन और तगड़ा है, इसीलिए लोगों के दिमाग खराब होता है स्टेट्स में ना। इन हाउ मेनी वेज कैन ए नंबर बी चूजन फ्रॉम 1 to 20, नंबर को चूज करना है दैट इट इज ए मल्टीपल ऑफ 2 और 3, 2 या 3 का मल्टीपल हो, कितने तरीके से चूज कर सकते हैं? इन हाउ मेनी वेज कैन ए नंबर बी चूजन। पहले तो हम ऐसे 2 और 3 से के मल्टीपल निकाल लेते हैं 1 to 30 के बीच में।
1
तो
to 20 आई थिंक 60 होगा।
एक पहला 2 होगा, फिर 3 होगा, फिर 6, फिर 7 8, फिर
60 मेरा
9,
भी आ रहा है।
फिर 10, फिर 12, फिर 13 14 15 16 17 18 19 20। 1 2 3 4 5 6 7 8 9 10 11 12 ही तो हुए।
2 और 13 दोनों बोल रहा है ना, तो 2 के अलग निकालने पड़ेंगे, 3 के अलग निकालने पड़ेंगे।
2 और 13 है ना, 2 या 3 से होना चाहिए।
तो और है ना, तो 2 के लिए अलग निकालो, 3 के लिए अलग निकालो और दोनों को प्लस कर दो।
तो उसमें तो आपकी डबलिंग हो जाएगी ना।
लेकिन इसमें ऐसा बोल नहीं रहा है ना कि रिपीटिशन में करना है या नहीं करना है।
नहीं नहीं नहीं, क्या कह रहा है कि इन हाउ मेनी वेज कैन ए नंबर बी चूजन, कितने तरीके से नंबर को चूज किया जा सकता है। तो सवाल का मतलब समझिए, सवाल कहने का मतलब आप केवल एक एक नंबर चूज कर रही हैं, या 2 को ले लिया या 3 को ले लिया। हाउ मेनी वेज कैन बी चूज, हमारे ख्याल से ऐसा है कि एक बार हमने 2 लिया, दूसरी बार हमने 2 3 ले लिया, तीसरी बार हमने 2 3 6 ले लिया, फिर हमने 2 3 8 ले लिया, लाइक दैट। हेलो?
हाँ
तो देखिए देख लेंगे, सही भी हो सकता है गलत भी, लेकिन मैं अपना कैलकुलेशन ये कर रहा हूँ कि 2 से 3 से 2 और 3 से डिवाइड होने वाले नंबर ये हो गए 2 3 6 8 9, इसके अलावा कोई छूट तो नहीं रहा। तो 3 4 4 छूट रहा है ना, 4 भी तो है। 2 3 4 5 6 7 8 9 10 11 नहीं 12 13 नहीं 14 15 16 17 नहीं 18 19 नहीं 20, ठीक है। तो ये होगा 1 2 3 4 5 6 7 8 9 10 11 12 13, 13 नंबर हैं। तो 13 नंबर को हमें चूज करना है, तो हम कितने तरीके से चूज कर सकते हैं? तो इसमें देखिए ऑप्शन क्या है कि हमने एक नंबर को 13 को फिक्स कर दिया, फिर हमारे पास कितने ऑप्शन बचे? 12 दूसरे नंबरों के लिए। फिर अगर हमें पहले 2 फिक्स कर दिया तो फिर हमारे पास 11 बचे, यानी कि 13 का फैक्टोरियल आएगा मेरे ख्याल से, 13 इंटू 12 इंटू 11 इंटू 10, ऐसे लाइक करके 1 तक आना चाहिए। हाँ, क्या कहते हैं?
13 फैक्टोरियल लिखते हैं क्या?
एक बार करके देखते हैं क्या ऑप्शन आता है, सही गलत होगा कुछ होगा। 13 फैक्टोरियल होता कितना है, पहले तो गूगल से निकाल लें। इसके उसमें नहीं होता ना कैलकुलेटर में 13 का फैक्टोरियल। 13 का फैक्टोरियल इतना बड़ा नंबर आया 6227, इतना तो नहीं होना चाहिए
ये
कैलकुलेशन।
नहीं होगा।
ये नहीं होगा है ना, कहाँ पे ये था। तो क्या हो सकता है, इन हाउ मेनी वेज कैन ए नंबर बी चूजन फ्रॉम 1 to 20?
तो इसमें वेज पूछा है ना, तो जो बोल तो नहीं रहे,
हाँ नंबर कह
हमारे
रहा है,
पास
हाँ सॉरी
13,
सॉरी, हाँ
हाँ
नंबर कह रहा
नंबर
है।
है ना,
हाँ
तो
नंबर
13 नंबर ही तो हुए।
13 ही होंगे ना। हाउ मेनी वेज,
करके देखते हैं, फिर देखते हैं सही है कि नहीं।
ओके ओके ओके, 1 to 20 so that it is a multiple of 20, ठीक है 13। जय भोलेनाथ। ओह माय गॉड, सही है। आप लोग भी अपने टैब में खोल के टिक कर लीजिए।
कर लिया।
कर लिए,
नहीं, मेरा भी नहीं हुआ।
कर लो।
हो गया।
हो गया। तो अब 5.2 लेक्चर देखते हैं।
Not everything that's worthy comes free.
क्या?
So now let's introduce a very important concept which is referred to as notation or a factorial. Now let's look at a race. It's a 100-meter race and I have 8 people who are running in this race. So they are distinct people. So I have
वॉइस
person
अच्छे
1.
से नहीं आ रही है।
कर रहा हूँ।
So now let's introduce a very important concept which is referred to as a factorial notation or a factorial. Now let's look at a race. It's a 100-meter race and I have 8 people who are running in this race. So they are distinct people. So I have person 1, person 2, person 3, person 4, person 5, person 6, person 7 and person 8. These are all distinct people. Okay, they are running this race. Now, what are the possible ways these athletes can finish the race? So, I have position 1, 2, 3, 4, 5, 6, 7, 8. These are the positions. That is what I mean by this is the first position of finish, the person who comes second and the person who comes 8, because there are only 8 people. These are the only finishing positions. So, what is it I am interested in? I am interested in knowing how many orders of finish that is possible when 8 people are participating in a particular race. Okay, I am not assuming any ties now. I am assuming that there is a clear ranking or a clear order of finish. So now let's look at this position, and I am also assuming that all the 8 of them are equally capable. So there could be anybody can come first on any given day, and the difference is not going to be too much. Now how many choices do we have for the first person? So if I put person 1 here, just a hypothetical situation, then person 1 cannot appear in any other position because he has already come in the first position. So given that person 1 is in the first position, person 1 is not available for any other position. So for person 2, the position 2, I have only a choice of 7 people because person 1 has already occupied the first position. So suppose person 2 comes to the second position. For the third position, I do not have both person 1 and person 2. I have only a choice from the other 6 remaining, and suppose person 4 is in the third position. Okay. For the fourth position, I have only 5 choices. It could be person 7 and so forth. I have person 8, I have person 6, I will have person 3 and I have person 5. So this is one order. Okay. So if I am looking at it, the number of choices to fill in the first position, I have 8 choices. If I fill up the position 1 with one of these people, for the second thing I have only 7 choices. I have 6 choices here, I have 5 choices here, 4, 3, 2 and 1. These are the choices I have to fill in these positions from the available number of people. These are distinct people. So I can, in other words, if I term the first action is to choose from these 8 people, number of people who would fill in the first position. Second action is to come up with the number of people who will fill in the second position, and so forth. The 8th action is number of people who will fill in the 8th position. Then I can apply my multiplication rule of counting to know that the total number of possible ways in which all these 8 athletes can actually complete the race is going to be 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is a large number. Okay. So this is basically, it helps me. So instead of writing as 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, can I have a simpler way to express this number? Okay. So what is the simpler way to express this number, which is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is where I define a notation which is referred to as a factorial notation. What is a factorial notation? Factorial notation is the product of the first n positive integers. What are the first n positive integers? 1 into 2 into 3 up to n. This product is what I refer to as n factorial. Okay. So this is the notation is n with an exclamation mark, and I refer to it as it's called n factorial, and it is written as n factorial. By convention, 0 factorial is equal to 1, 1 factorial is also equal to 1. So now if I have this factorial notation, my earlier problem becomes very simple. I can write that the total number of ways I can express it is equal to 8 factorial, which is far more elegant than writing it as 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. I can just express it as 8 factorial. So this factorial notation is extremely useful. Again, let's go back to looking at this example where I have 3 shirts. Now the first choice is, again, suppose in the same choosing example, this one I have only 3 people, and this is again the order of finish of these 3 people are wearing a yellow t-shirt, a blue t-shirt and a green t-shirt. The first order could be the yellow t-shirt is 1, the blue t-shirt is second, the green t-shirt is third. The second is yellow t-shirt is first, green is second, blue is third. So you can see that the total number of ways is 1, 2, 3, 4, 5, 6. The number of objects, distinct object n is equal to 3, and you can see that n factorial, the way I defined it, was 3 into 2 into 1, which is giving me a 6 here. Okay, total number of choices, which is n factorial, which is equal to 6. Okay. So now let's go back and look at the factorial notation. 5 factorial. What is 5 factorial? 5 factorial is 5 into 4 into 3 into 2 into 1. Now if you look at this portion, it is 4 into 3 into 2 into 1. I know this is nothing but 4 factorial. Hence, I have 5 factorial, which can be written as 5 into 4 factorial. In other words, what we say is, similarly, if I look at 6 factorial, 6 factorial is 6 into 5 into 4 into 3 into 2 into 1. Now, this portion is nothing but 5 factorial. So, I can write 6 factorial as 6 into 5 factorial. In other words, for any integer n factorial is n into n minus 1 into n minus 2 times 1. This is n minus 1 factorial. So, the first expression is n factorial equal to n into n minus 1 factorial. Okay, so I have n factorial is n into n minus 1 factorial. Now, again look at the following. I have 5 factorial is 5 into 4 into 3 into 2 into 1. So, I can write this also as 5 into 4 into 3 2 into 1, where this is nothing but 3 factorial. So, I can write this as 5 into 4 into 3 factorial. Similarly, if I have a 6 factorial, which is 6 into 5 into 4 into 3 into 2 into 1, I see that this is equal to 4 factorial. So, I can express 6 factorial as 6 into 5 into 4 factorial. So, you can see that if I have 5 factorial, I can write it as 5 into 4 into 3 factorial, 6 factorial or 6 into 5 into 4 factorial. So, in general, for any I less than or equal to n, so my n, if it is 5, what are the i's that are less than or equal to n? I can have I equal to 1, I can have I equal to 2, I equal to 3, I equal to 4 or I equal to 5. I have n factorial, which is 5 factorial, which is n, which is equal to 5 into your 4. So, if my I equal to 1, okay, n minus I is 4 factorial. So, it is 5 into 4 factorial. I equal to 2, it is 5 into 4 into 3 factorial. I equal to 3, I have 5 into 4 into 3 into 2 factorial. I equal to 4 is 5 into 4 into 3 into 2 into 1. Okay. So, this is another expression which we can use, and these will help us simplify a lot of expressions when we are encountering counting, when we do our permutations and combinations and probability problems. Now, let us look at further simplification of factorial notation. Now, what is the factorial notation we are looking at? What is 6 factorial? 6 factorial I know is 6 into 5 into 4 into 3 into 2 into 1. From my first definition, 3 factorial, I just retain that way. I recognize that this quantity is nothing but 3 factorial. So, I can cancel out this with this and I get 6 factorial by 3 factorial is nothing but 6 into 5 into 4. Okay. Okay, which is 120. Now, let us look at the next problem. 6 factorial into 5 factorial. So, I have a 6 into 5 into 4. We have already seen 6 factorial by 5 factorial is 6 into 5 into 4. Now, 5 factorial by 4 factorial is going to be 5 factorial divided by 4 factorial into 4 factorial. So, I can see that I can simplify this by cancelling out the 4 factorial with 4 factorial, and what I have is 600 as the answer. Now, sometimes you might want to express a product in terms of factorials. So, suppose the example I have taken here is to express 25 into 24 into 23 in terms of factorials. Let me write it. I am having 25 into 24 into 23. I am going to multiply the numerator. So, I am going to write it as a fraction into 21, so forth with 1. I only want this portion. I only want this portion. So, I need to divide the denominator with this portion which I have put with double line. And what is that portion? That portion is nothing but 22 into 21 into 20 into 2 into 1. Now, what is this denominator? Denominator is nothing but 22 factorial. My numerator is nothing but 25 factorial. So, I can express this 25 into 24 into 23 as
क्या कर रहे हो भाई सब लोग ना?
हाँ हाँ देख रहे हैं।
बात खत्म होने वाला है ये लेक्चर.
शिल्पी सो गई क्या?
25
नहीं।
factorial by
अच्छा ठीक है।
22 factorial. Okay. So, I can express this 25 into 23 as 25 factorial by 22 factorial. Okay. So, this notation of expressing the product in terms of factorial would come in news when we learn more about permutations and combinations. So, in summary, what we have learned today is we introduce the factorial notation and how do we simplify expressions using the factorial notation. That is what we have learned.
ठीक है, क्लियर हुआ ये? बोल सकते हैं एक्टिविटीज.
They have a monumental journey ahead of them, through wind and rain.
Okay. In how many ways can you arrange the alphabets of the English language if you were to form all the words that have 4 alphabets in them? In how many ways you can arrange the alphabets of the English language? English में 26 alphabets हैं, तो पूछा कितने तरीके से arrange कर सकते हैं if you were to form all the words, if you were to form all the words that have 4 alphabets in them. मतलब हमें वैसे वर्ड्स बनाना है जिसमें 4 अल्फ़ाबेट हो और 26 लेटर्स है, तो कितने तरीके से अरेंज हो सकता है?
26 factorial divided by 4 factorial.
क्या लॉजिक है? How many ways can arrange the alphabets of the English to have from all the words that have 4 alphabets? मतलब कि देखिए
नहीं नहीं 4 आई थिंक 4 माइनस हो जाएगा.
मेरे हिसाब से डी वाला होना चाहिए.
डी वाला.
हाँ.
हाँ देखिए ये 4 प्लेसेस हैं, हमें पूरा एक वर्ड्स में 4 प्लेसेस हैं फिट करना है. पहले पर हम 26 ऑप्शन है, दूसरे पर 25 है, फिर इस पे हो जाएगा 24 और इस पे हो जाएगा 23. तो ये हो जाएगा इसका मल्टीप्लिकेशन. तो ये चीज़ है होगी 26 फैक्टोरियल अपन 22 फैक्टोरियल करेंगे तो 22 तक कैंसिल हो जाएगा, 23 4 5 6 ये आएगा. ठीक है.
हाँ
नेक्स्ट क्या रहा है कि the value of the expression n minus 2 factorial upon n minus 1 factorial is, की वैल्यू क्या है? n minus 2 factorial 4 और n minus 1 factorial. तो नीचे निकाल देंगे, अगर ये n minus 2 factorial है और नीचे में से n minus 1 बाहर निकाल देंगे तो अंदर -1 यानी कि n minus 2 बचेगा फैक्टोरियल.
फर्स्ट वाला होता है.
ये कैंसिल हो जाएगा तो 1 upon n minus 1. third one. The value of the expression factorial 10 upon factorial 3 into factorial 5. Factorial 10 upon factorial 3 to factorial 5. तो फैक्टोरियल 5 तक का ये कैंसिल हो जाएगा, तो ये बचेगा 10, 9, 8, 7 और 6, और नीचे हो जाएगा 3 इंटू 2 1, तो ये 6 कैंसिल हो जाएगा, तो ये हो जाएगा 10, 9, 8, 7 का मल्टीपल, तो ये हो जाएगा
5040.
हाँ 50-40.
5040. आपकी तबीयत नहीं सही है क्या?
क्या?
खांसी आ रही है कुछ, तबीयत सही है?
हाँ.
Suppose you have a 6 balls. Each ball has a number marked on it. You also have 6 slots that you have to fill with the balls. How many different ways can you fill these balls? तो factorial 6 हो जाएगा. So 6 into 5 into 4 into 3 into 2. पांचों को 20.
720.
720.
720. सही है सारे आंसर? सही.
सारे सही है.
आप लोग
सही
कर
है.
सकते हैं, कर लीजिए आप.
हो गया.
हो गया.
हाँ.
Hello everyone, in this tutorials we will be looking at the problems on basic principles of counting, which are additional rule of counting and the multiplication rule of counting. Along with that, we will use the concepts of factorials to solve these problems. Okay, so the first question is, in a building 6 men and 4 women are staying. Among them 3 married couples. There are exactly 3 married couples. In how many ways can you guess who the couples are? Okay, so remember we need to use only additional rule of counting and multiplication rule of counting to solve this problem. Okay, so there are 3 married couples. Okay, so one couple includes 1 man and 1 woman. So similarly, let's take this as like M1 W1. There are M2 W2 and we have third couple M3 W3. Okay, but in total I have 6 men. Okay, I have M1, M2, M3, M4, M5 and M6. Okay, I have 6 men and I have 4 women. W1, W2, W3, W4, and we need to find the number of ways in which we can map one man to woman here. Okay, we need to match one man from this six men, okay, to one of the women. Similarly, we need to do that we need to do that for 3 times, since we need 3 couples. Okay, example, it could be M1 woman 2, okay, they could be a couple, and M2 W1 and M5 W4. This could be one combination. Okay, this could be one way in which 3 couples could exist in that building. Similarly, we need to find all the other combinations. Okay, so how do we do that? Okay, the first thing is we have 4 women, okay, and there are 3 couples, right? So that means 3 women are married. So the first thing we could do was we could identify these the 3 women among those 4 women who are married. Okay, so it could be the woman 1, woman 2, woman 3, the W1, W2, W3, or W2, W3, W4. In a way, like we need to. Okay, I'll write out the combinations here. It could be W1, W2, W3. Okay, the 4th woman is not married, or it could be the first woman who is not married. So the combination would be W2, W3, W4, or it could be the second woman who is not married. So that implies woman 1, woman 3, and woman 4 are married, or it could be the third woman W3 who is not married. So the combination would be W1, W2, W4. These are the 4 total possible ways, okay, in which the woman could be there. So and for these 3 women who are married, okay, their husbands will be 3 among those 6 people. Okay, so the way it could be is, let's say for each of the combination we have the first woman, we have a second woman, we have third woman. Okay, this first woman could be W1 here, this first woman is W1 here, W1 here, W2 here, and W1 here. Okay, it could be in any way. Okay, so for each of those women, for the first woman there are M1, M2, M3, M4, M5, M6, right? We have six men, right, in the building. So one among those 6 men could be the husband for the first woman. So the total possible ways for, like, if you use the R principle, we could use the R principle here. So for the first woman, the husband could be M1 or M2 or M3 or M4 or M5 or M6. So the total ways in which the husband for the first woman could be in 6 ways. Since it is addition rule of counting, 1 plus 1 plus 1 plus 1 plus 1 plus 1, so that will lead to 6. Okay, so if we leave that person out, okay, let's say this M1 is the husband for the first one, okay, and that leaves out 5 options for the second woman. Okay, and anyone among those remaining 5 men could be the husband for the second woman. Okay, so it could be either M2 or M3 or M4 or M5 or M6. So again, through addition rule of counting, it could have 6. Like for the second person, or for the second woman, there are 5 possible ways in which the husband could be selected. Okay, for the third woman, let's say this M4 is the husband for the second person, so that leaves out 4 options for the third woman. Okay, and any one person among those 4 people could be the husband for third woman. So that could work out in, so one among those 4 people could be the husband for third woman. Now for the first woman there are 6 possibilities, and for second woman there are 5 possibilities. For third woman there are 4 possibilities. So in total, if you look at it, there are how many ways? For first woman 6, and we need to select the husband for the first woman and second woman and third woman. So the total possible ways would be 6 into 5 into 4. Remember why I am using this multiplication, because it is AND operation here. Okay, we need to select the husband for first woman, and we need to select the husband for second woman, and we need to select the husband for third woman. So the total possible ways are 6 into 5 into 4. Okay, these are the total possible ways in which the husbands could be there. And how many total possible ways of women we have? We have 4 ways, right? So that is these 4 ways comes like, since we have 4 women and we need to select these 3 women. Okay, these 3 women could be selected in 4 ways as we have seen before: W1, W2, W3, or W1, W3, W4, or W2, W3, W4, or W1, W2, W4. Okay, so It could be the 6 into 5 into 4 combination. It could be for this, or it could be for this, or it could be for this, or it could be for this. So the total possible ways would be 6 into 5 into 4 plus 6 into 5 into 4 plus 6 into 5 into 4 plus 6 into 5 into 4. Or like we could directly multiply this into 4. Okay, that is the total number of ways in which there are exactly 3 married couples is 6 into 5 into 4 is the correct answer. So the answer is 6 into 5 into 4 into 4. Thank you.
Do you want to grow your YouTube channel? You should consider getting TubeBuddy. I've been using TubeBuddy for
हाँ ये 6 into 5 into 4 तो आ गया, ये लास्ट में 4 क्यों किया ये नहीं क्लियर हुआ।
IIT मद्रास से कोचिंग दे रही है ऑनलाइन, समझे? तो वो उनका
यहाँ पे जो कैलकुलेशन किया है, यहाँ पे ऊपर वुमेन का 4 सेट बनाया है ना, और W1 W2 W3 W1 W3 W4 W2 W3 ये 4 सेट वुमेन का है। तो एक सेट में जब बात किया कि जो एक सेट में 3 वुमेन है 1 2 3, इस 1 2 3 में जो सेट बनेगा वो 6 5 4 मेन के साथ जो कॉम्बिनेशन बनेगा वो 6 5 4, यानी कि एक सेट में 6 into 5 into 4 का कॉम्बिनेशन बनेगा। इसी तरह 4 सेट वुमेन के हैं तो इस into 4 करते हैं।
हाँ तो 4 से करते, ठीक है ओके।
नेक्स्ट देखते हैं।
Hello everyone. So in the second question they are mentioning that 4 dice are rolled, a number is observed on each face of the die, okay, as outcome. So each of the dice outcome is noted. How many ways are there such that each die shows a different number on the face, okay. So what they were saying is that let's say there are 4 dice, okay, it's die 1 die 2 die 3 die 4, and whatever outcome this is having, and let's say this is like x1, this is the outcome on this is x2, this is x3, and this is x4, okay. These are the 4 outcomes of the die, and each of this x1 x2 x3 x4 should not be equal. So x1 should not be equals to x2, should not be equals to x3, should not be equals to x4. So suppose if x1 occurs on the, suppose let's say the 5 occurs on the first die, so the 5 should not be occurring on any of the other 3 dice, okay. Suppose here 1 occurs, so in these 3 outcomes 1 should not be occurring, and let's say on the first die 1 occurs and on the second die 2 occurs, so 1 and 2 any of these should not be occurring on third and fourth day, okay. So it could,
तो बताइए इस क्वेश्चन में क्या लगता है क्या होना चाहिए?
इसमें 8 डाइस में 6 फेसेस होंगे ना, तो फर्स्ट में अगर 6 टाइम्स में आया है,
हाँ,
सेकंड में वो 6 मतलब 8 तो खत्म हो जाएगा तो 5 बचेंगे,
5 हो जाएगा,
फिर 4 हो जाएगा, फिर 3 हो जाएगा।
देखते हैं।
could be like 1 4 5 6 or 1 2 4 3. Here you see that each of the outcomes for 4 dice are different. It cannot be like 1 1 4 3, okay. Here the outcomes on first die and second die are equal. That's not the case, okay. So we should be calculating in such a way that all the outcomes are different. So let's say, okay, now that we have 4 dice, first die, second die, third die and fourth die, okay. For the first die, it could be any of this 1 2 3 4 5 6 could be possible, okay. Since these are first one, any of the outcome could be possible. So for the first die, the number of ways it could happen is either 1 2, 3, 4, or 5 or 6. So by the addition rule of counting, for the first die, the outcome could be any of the 6. So the number of ways the outcome of first die could happen is 6 ways. Now once the first die is rolled, okay, let's say one of these 6 outcomes will be happening. Let's say 3 happens. Okay. Now for the second die, this 3 cannot happen, but any of this 1 or 2 or 4 or 5 or 6 can happen. So the total number of ways in which the outcome of second die could happen is 5 ways. Again, by addition rule of counting, we have 5 possible ways. Okay, that is 1 can happen, or 2 can happen, or 4 can happen, or 5 can happen, or 6 can happen. Okay, so the total number of possible ways for second die is 5 ways. Okay, remember that here 6 is not the outcome, it is the number of ways. Okay, 6 ways, 5 ways. Similarly, let's say a particular outcome, okay, 2 happened on the second die. Now for the third die, we are left out with 4 options. Okay, either 1 can occur, or 4 can occur, or 5 can occur, or 6 can occur. So the number of ways for third die is 4 ways. Okay, and similarly, okay, let's say 5 occurred on third die. The number of possible outcomes for fourth die would be 1 or 4 or 6. So the number of possible ways is 3 ways. Okay, since we need the total number of possible ways should include the outcome on first die and second die and third die and fourth die. So the total possible ways in which the different outcomes could occur is 6 into 5 into 4 into 3. Okay, this can be written as 6 factorial divided by 2 factorial. This is the answer. And remember why I multiplied it. It is because we are having AND operation there. Okay, the total outcomes, it should be having the outcome on first die and second die and third die and fourth die. We are using AND operation there. So whenever we use AND, we will be multiplying. Whenever we are using that AND operation, multiplication sign will be there. Okay, multiplication for AND, and when we are using R, it will be addition. Okay, addition of number of possible ways. So here the number of possible ways for first die is 6, and the number of possible ways for second die is 5, and the number of possible ways for third die is 4, and the number of possible ways for fourth die is 3. Since the total possible ways include the outcomes on first die and second die and third die and fourth die, we are multiplying the possible ways for first die, second die, third die and fourth die. Okay, so this will be the end of second problem. Thank you. Hello again. Okay, the question is, a fair die is rolled and a fair coin is tossed. How many different ways of pairs outcome of a die and coin are there? Okay, so we know that for die the possible outcomes are 1. The possible outcomes are 1 or 2 or 3 or 4 or 5 or 6. Okay, these are the 6 possible ways. For the coin, the outcome could be tail or head. Okay, so the pairs of outcomes should be 1. The outcome of die could be 1, and the outcome of coin could be tail. So this is 1 pair, or it could be 1 head, or it could be 2 tail, 2 head, and so on. Okay, so let us use the basic principles of counting to solve this problem. So for the first way, right, for die, we have this for die, and for coin. Okay, fair coin. So for die, the possible outcomes are, the number of possible outcomes are 6, right? Either it could be 1 or 2 or 3 or 4 or 5 or 6. So by addition rule of counting, the total number of possible ways for outcome of die is 6. Okay, and for coin similarly, either it could be tail or head. So it will be 1 plus 1, 2 ways. The total number of possible ways in which the outcome of coin can happen is 2 ways. Now the pairs will be 1 die and coin, right? So they both commonly make a pair. So since we are using that AND operation there, okay, the outcome of a die and outcome of coin, this AND, because of that AND, so the total number of pairs will be equals to 6 into 2. This into occurs because the possible outcomes for die is 6 and the coin is 6. So the total possible outcomes for die and coin combined together, which make as a pair, is equal to 6 into 2, that is equal to 12. Okay. If you want to solve it laboriously, you could do it in this way. You could just write out all the possible outcomes. We have written out for 1 tail, 1 head, 2 tail, 2 head. It could be 3 tail, 3 head, or 4 tail, 4 head, 5 tail, 5 head, 6 tail, 6 head. These are the only possible outcomes, right? So the total possible outcomes are, if we add this up, it could be this or this or this. So by addition of counting, we can just add them up. It will be here 4, 1 plus 1 plus 1 plus 1, 4. And again we have here 4 and 4. So yeah, total we'll have 12 outcomes, which we got directly by using the addition rule and multiplication rule of counting. Thank you. Hello statistics students. So the next question is, how many 4-digit numbers can be found using the digits 0 to 9? The first and second numbers are 2 and 8 respectively. Repetition of numbers is not allowed. So the 4-digit number could be the first digit, second digit, third digit and fourth digit, right? They already mentioned that the first and second numbers are 2 and 8. So the first digit is 2 and the second digit is 8. Okay, now we are left with 2 more blanks to be filled, right, for the 4-digit number to be found, and it could be any of the digits from 0 to 9. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, it could be any of this, but they have mentioned repetition of numbers is not allowed. So already this 2 cannot be there since it is already filled in the first position. So 2 we can strike it out. Similarly 8 cannot be there, so 8 we can strike it out. Now we are left with 2 options, okay, 2 blanks to be filled. So since 2 and 8 are already filled, we have 8 more numbers, and out of this we need to select 2 numbers for this remaining 2 places, right? So let's take this third place. For third place we have 8 options. Either it could be 0 or 1 or 3 or 4 or 5 or 6 or 7 or 9. Okay, so total there are 8 possible ways for third place to be filled. So we have 8 ways there. Okay, let's say for in this place we have filled with 1, so it could be 2, 8, 1. Okay, and we are left with the fourth place, fourth blank. So let's since this one is filled, okay, since this one is filled, we'll just strike it out. Now we are left with 7 more options to fill in the last blank. Okay, so that means the total number of possible ways in which we can fill this fourth place is 7 ways. Okay, for each possible option, for each possible way in this third way, there are 7 possible ways in which we could fill the fourth blank. So the total number of ways in which this third blank and fourth blank could be filled is 8 into 7, because since the third place should be filled and the fourth place should be filled, since we are using that and there, okay, so the number of possible ways this third place could be filled is 8 ways and the fourth place could be filled is 7 ways. So the total number of possible ways in which the third place and the seventh place could be filled is 8 into 7 ways. That is equals to 56. Remember, again I am repeating this. Why are we multiplying this? Because we are using that and there. Okay, for the total number of possible ways of arrangement, when we are using and, we will be multiplying the total number of possible ways for A and B. Okay, that is if A occurs in if A occurs in n1 ways and B occurs in n2 ways, the total number of possible ways in which A and B both can occur is n1 into n2 ways. Similarly here, the n1 is 8 and the n2 is 7. So the total number of possible ways is 8 into 7, which is equal to 56 ways. Thank you. Hello statistics students. So in this question we have we have Lakia who has 5 different letter blocks. They are asking for how many different words of more than 4 letters, those words could be meaningless, can be formed by using these 5 letters without repetition. So let's say the 5 letters are letter 1, okay, letter 2, letter 3, letter 4, and letter 5. Okay, so when we are forming these 4 or 5 letter words, okay, 5 or 4 letter words, since it should be more than 4 letters, it could be 5 also. There cannot be repetition. That is L1, 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 L1. This combination is wrong. This is completely wrong. So what we should look at is essentially different ways of using them. Right? That is L1, L2, L3, L4. This is possible since all of these letters are different. So using these different letters, we should be forming 4 letter words or 5 letter words. Okay, and they need not make grammatical sense. So those words could be meaningless. They need not exist in the English dictionary, is what it says. Okay. Now let us look at the first option of like 5 letter words. Okay, we need 5 letter words. So obviously we need to use all the 5 letters. The L1, L2, L3, L4, L5 all should be used. So the first way could be any of these 5 letters could occupy the first place, right? So let's say so if you look at it, the total number of possible ways is 5 ways here for the first place, and for the second place, if you remove one letter, okay, and place it here, for the second place we are left with only 4 places since already one letter is already taken. So that leaves out 4 ways for third one. Sorry, that leaves out 4 ways for second letter, and for third place to be filled, we have similarly, since 2 letters are already taken away, there are 3 letters to be filled in the third place. So the total number of ways in which the third place could be filled is 3 ways. Similarly, for fourth letter it will be 2 ways, and for the last it will be 1 way. This is exactly similar to arranging n objects, n distinct objects in that is equals to n factorial, right? Which was in. So this is equals to 5 factorial. Since the first place is filled with 5 ways and second place 4 ways, third place is in 3 ways, second place 2 ways. The total number of ways in which the first place and second place and third place and fourth place and fifth place could be filled is 5 into 4 into 3 into 2 into 1. Since that and rule is there, we will be multiplying. Okay, we will be using that multiplication. Okay, so the 5 letter words are formed. Now we need to look at the total number of 4 letter words that could be formed. The first thing is when we are going to take 4 letter words, we need to pick only 4 of this 5 letters and then fill it here. So there will always be one letter which is not used. Let's say we have L1, L2, L3, L4. Okay, this is the 4 letter word. That means L5 is not used. Similarly, L1 need not be used, or like there could be a possible ways of like L2, L3, L4, L5 where L1 is not used, L2 need not be used, L3 need not be used, and L4. Okay, so total there are 5 ways in which one letter could be left out. Okay, 5 ways in which one letter could be left out. That we need to be taking into account for seeing the total number of 4 letter words that could be formed. Okay, so let's take the case of when L5 is left out. That is when we have L1, L2, L3.
इसमें 4 लेटर क्यों बना रहा है? तो दिया है कि मोर देन 4 लेटर होना चाहिए ना.
दिया तो है.
Laksha has 5 different letter box. How many different words of more than 4 letters? तो more than 4 letters दिया है तो 4 से ज्यादा होना चाहिए, 5 letters होना चाहिए. 5 लेटर का तो उसने काउंट किया फैक्टोरियल 5, फिर 4 का क्यों काउंट कर रहा है? समझ नहीं आ रहा. शिल्पी आपको?
मुझे तो नींद आने लग गई.
2 मिनट ब्रेक लीजिए, कुछ देखते हैं एंटरटेनमेंट, फिर देखेंगे. ये वीडियो देख के बाद थोड़ा सा ब्रेक लेते हैं. क्या कहते हैं अक्षरा? एक मिनट.
सो गई क्या?
नहीं, अक्षरा तो है. इसको वीडियो एक बार कंप्लीट करते हैं, फिर बात करते हैं.
L3, L4 letters. Okay, this is one possible way. The total possible ways is similarly. This is similar to the previous problem where we have 5 letters and we are arranging them in 5 places. Now we have 4 letters: L1, L2, L3, L4. Those should be arranged in four spaces. So that can be done in 4 factorial ways. Similarly, n factorial. If you want to see how that comes out, so that is simple. For the first place we have 4 ways, and for second place we have 3 ways. For third place we have 2 ways, and for fourth place we have 1 way. So that will be equal to 4 into 3 into 2 into 1, which is equal to 4 factorial. Okay, but this is for the case of when L5 is left out. Okay, when L1 is left out, similarly we'll have 4 factorial ways. When L2 is left out, we will have 4 factorial ways, and when L3 is left out, we'll have 4 factorial ways, and when L4 is left out, we'll have 4 factorial ways. So the total number of 4 letter words that could be formed is 4 factorial into 5, because it could be either this or this or this or this or this, right? That is the 4 letter words could be formed excluding L5. The 4 letter words could be formed excluding L1, excluding L2, excluding L3, and excluding L4. Since we are using R there, R operation there, we are adding all the possibilities for each case. That is 4 factorial plus 4 factorial plus 4 factorial plus 4 factorial plus 4 factorial, which is equal to 4 factorial into 5. This is the 4 letter words. Okay. And for 5 letter words, as we have already seen, we have 5 factorial. So the total number of 4 letter words or 5 letter words that could be formed is, again, since we are using 4 letter words or 5 letter words, we need to add the possible case of 4 letter words and 5 letter words. So that will be 4 or 5 letters is equals to 5 factorial plus 5 factorial. 5 factorial is equals to 120, so that makes it just 120 into 2, which is equals to 240. Yes. So the total number of words of 4 letters or 5 letters that could be formed using 5 different letter blocks without repetition is 240. Yes. Thank you.
They took my feedback. They recorded a video that they will send to IIT Madras. But it was really very stressful. It took me some good 15 minutes to settle down because the student right next to me.
जो किया था उसने मतलब 4 लेटर का भी काउंट किया था और 5 लेटर वाला भी काउंट किया था। 120
वॉइस नहीं आ रही है आपकी।
मैं कह रहा था कि इस वाले एग्जांपल में उसने 4 लेटर का भी काउंट किया था और 5 लेटर का भी काउंट किया था, इसलिए 120 प्लस 120 240 हो गया था।
वैसे अगर सिर्फ मोर देन 4 लेटर के लिए पूछेंगे तो फिर 5 फैक्टोरियल वाला ही लिखेंगे ना।
मीनिंग तो वही बनता है, लेकिन अब इसमें तो 4 का भी काउंट किया था।
हाँ, और इसमें नीचे जो दिया है वो 4 लेटर वाला हम लोग मतलब उन्होंने जो कैलकुलेट किया था वो आया था 4 फैक्टोरियल, और लास्ट में जो इन्होंने स्टेप किया था 4 और 5 फैक्टोरियल, तो उसमें 5 फैक्टोरियल प्लस 5 फैक्टोरियल किया था। ऐसा क्यों किया?
4 लेटर का भी 5 फैक्टोरियल हुआ क्योंकि आपके पास लेटर 5 हैं, तो आप 4 लेटर के लिए बनाना है तो आप एक बार में 4 लेटर
5
आप एक बार में 4 लेटर लेंगे, 1 to 4 ले लिया तो उसका 4 फैक्टोरियल हुआ। फिर दूसरी बार में एक दूसरा लेटर छोड़ दिया तो बाकी 4 लिया, तो इस तरह एक एक लेटर निकाल के 5 टाइम्स आपको 5 चांस मिल जाएंगे, तो यानी कि 4 फैक्टोरियल मल्टीप्लाई 5 हो जाएगा, यानी 5 फैक्टोरियल हो जाएगा।
ठीक है ठीक है।
ओके, थोड़ा सा नींद भगाने वाला कुछ काम किया जाए। शिल्पी, आप सो रही हैं कि जग रही? हो गई। देखते हैं इसमें यूट्यूब पे है आप लोगों का इंटरेस्टिंग चीज, चला दीजिए जिससे नींद खुल जाए।
कुछ भी चला लीजिए।
नहीं, आप शिल्पी को नींद आ रही तो शिल्पी का इंटरेस्ट का चलेगा तो अच्छा रहेगा।
कुछ भी चलाइए, बस नींद भागना चाहिए।
नहीं, नींद भगाने से मतलब यह है कि आप आगे पढ़ने के लिए तैयार हैं कि नहीं, वो भी है ना, नींद तो भाग जाएगी। वैसे ये वीक खत्म हो गया, 2 ही लेक्चर थे, वे ट्यूटोरियल के बाद प्रैक्टिस और ग्रेडेड है। तो अगर हम इसको
हाँ
कर लेंगे तो कम से कम 1 वीक तो कंप्लीट हुआ पूरा, रहेगा कि हमने जगह तो 1 वीक हमारा कंप्लीट हो गया। और हम डायरेक्ट अब प्रैक्टिस पर
हाँ
चल सकते हैं, लेकिन ट्यूटोरियल देखने से थोड़ा सा आइडिया लग जाएगा क्वेश्चन किस टाइप के आएंगे और हमें कैसे करना है।
हाँ, 2 हैं, तो थोड़ा स्पीड बढ़ा के देख लेते हैं, जल्दी हो जाएंगे।
हाँ ठीक है, चलिए कुछ एक बार कुछ चलाते हैं यूट्यूब पे।
हम्म।
ये चूंकि हमारा लाइव चल रहा है तो पहले लाइव को तो रोकना पड़ेगा, इसमें आ जाता है कॉपीराइट। टॉप